Hello, class, and welcome to lesson 8.3, trigonometric applications or trig applications. So today we're going to be mixing all three of the trig ratios up. And as a reminder, folks, we use the acronym SOHCAHTOA. I'm going to write it on the top of the page. Please do that as well, so that we know when to use which ratio. Okay, so we're going to start with some warm-ups, making sure we know how to do SOHCAHTOA, and then we are going to get into doing our trig applications. All right, so let's get started with example 1. It says to calculate the value of x. An angle is given, folks, and it is going to be our reference angle. So we look to see what side of the triangle is your x on, and that's the hypotenuse. And then we say, where do we have our other information? We have it on the adjacent side. Okay, notice there's nothing in the opposite side, so I don't even include it, folks. Then I look over SOHCAHTOA and I say, which ratio has an O and an H in it? And you'll see that it's got the cosine ratio. So it's going to be cos of the given angle, which is 13 degrees, equals, remember, it's got the proper order, adjacent over hypotenuse. So it's going to be 7 over x. X is on the bottom, folks. So you do the switch. So you put an arrow in, write the word switch. So it's going to be x equals 7 divided by cos of 13 degrees. Plug that in your calculator, and let's round to one decimal place. So it's going to be 7.2. Haha, give me a second. My computer's doing something funny. 7.2 meters. All right. Okay, that's example A. B, ladies and gentlemen, we have an angle of 55 degrees. That becomes our reference angle. We look to find what side the x is on. The x is on the adjacent side. And the other side that has information is the opposite side. Okay, so now we're looking for a ratio that has an O and an A in it. Ladies and gentlemen, that's the tangent ratio. So we're going to go tan of the given angle, which is 55 degrees, equals the opposite, which is 14, over the adjacent side, which is x. It's on the bottom again, meaning x is on the bottom, so you do the switch. So it's going to be x equals 14 divided by tan of 55 degrees. And x equals 9.8 units are centimeters. Good. All right, so those are finding side lengths. Okay, now it asks us to find the value of angle K, sorry. So angle K is going to automatically be my angle of reference. So from that, ladies and gentlemen, what two sides do I have information in? I have them in my opposite side and my hypotenuse side. Okay, if I scroll up quickly to SOHCAHTOA, which one has an O and an H in it, ladies and gentlemen? That's going to be the first one, which is the sine. Okay, so it's going to be sine, and we don't know the angle, so we put in K, because that's what it says. Hey, there's funny guys, it spells sync. Okay, and again, that's in the proper order, equals the opposite side, which is 1.5, divided by the hypotenuse, which is 5. Remember, when you're finding an angles, folks, you have to use the sine inverse, or your inverse buttons in the calculator. And hopefully by now you know how to plug that in, no problem. Okay, and do that, folks. Plug in your calculator, and you should get angle K equals, I believe, 17 degrees. Let me quickly double check that, folks, because my writing's a little bad. So I'm just going to plug it in the calculator. Make sure, again, you're in degree mode. So I'm going to go second sine, opening bracket, 1.5 divided by 5, closing bracket equals, and yes, it's close. It's 17.45, so it's close to being 18, but it is 17 degrees. Okay, next one, ladies and gentlemen. Again, we're looking for angle K. That becomes our angle of reference. Where do we have information? We have it on the hypotenuse side and on the adjacent side. Look up at SOHCAHTOA, and you notice the CA part, which is the cosine ratio. So cos of K equals, and again, it's the adjacent over hypotenuse, so it's going to be 7 over 15. To find angle K, you have to do the cos inverse of this ratio, or the fraction. Plug it in your calculator, and you should get 62 degrees. Awesome. Now, for today's lesson, we're going to be taking these and putting them into some word problems eventually. Some will just do regular practice on making sure you know how to use SOHCAHTOA, but eventually we're going to get, last example, we'll get into some word problems, which means you got to read the problem first. Then you create or label a triangle. Don't forget your let statement, whatever letter you introduce. Identify the sides. Whatever side you're looking for, use SOHCAHTOA to determine the correct ratio to use. And I'm just going to put down here, right triangle only. Because later on, we're going to get to those oblique triangles where we're going to use a different strategy. Okay, so SOHCAHTOA is just right triangle only. And then we solve, use proper units with proper units, and then we use concluding statements. All right, so this is kind of like a practice like what we did in the warm-up, ladies and gentlemen. So we're just going to go over this a little quicker. We have our angle of reference, which is 23 degrees. The two sides that we have on, ladies and gentlemen, are our hypotenuse and our adjacent side. So if you need to write that in, good. If you're past that, you know what stages they are or what sides they are already, you don't need to write that in anymore because we're getting close to that, okay? So we're going to go cos because adjacent and hypotenuse is the cos ratio. So cos of 23 degrees equals 12 over x. X is on the bottom, guys, so you do the switch. So it's going to be x equals 12 divided by cos of 23 degrees. Okay, second question. Let's try see if we can figure this out without using identifying the sides. I will write this down again for those who may need it to help them. Okay, all right. So based on this angle, folks, what two sides do we have? We have the hypotenuse side, which is 3.5, and we have the opposite side, which is x. So we're looking for an O and an H, and that's going to be your sine ratio. So we're going to go sine of 61 degrees equals, remember it's got its proper order, so it's the opposite side, which is x, over the hypotenuse, which is 3.5. X is on the top, ladies and gentlemen, so we cross multiply. So x equals 3.5 sine of 61 degrees. Plug that in your calculator, and you're going to get x equals 3.1 centimeters. Cool. All right, so that was finding some side lengths. Okay, now we're going to go practice finding some angles. Okay, so solve angle D for each of the following. So this is angle D, ladies and gentlemen. What two sides? Again, I'll write SOHCAHTOA down to help those people. Okay, so again, apologize, back up the truck here. We got to angle D. What two sides do we have information on? We have information on the opposite side, which is here, and the adjacent side, which is here. So that tells us what ratio has an O and an A in it. That's the tan ratio, which is at the end. So you're going to go tan of D, because we don't know what D is, that's what we're trying to find, equals the opposite, which is 70.2, divided by the adjacent, which is 52.4. Okay, to find your angle, remember you got to use the inverse function. So we're going to go tan inverse of this ratio. Plug it in your calculator, ladies and gentlemen, and you should get 53 degrees. Please make sure that you're practicing actually plugging these in. Okay. Next question, again, angle D is our reference angle. So what sides do we have here? We have the opposite and the hypotenuse. So which ratio is that? That's the sine ratio, ladies and gentlemen. So sine of D equals, and go in order, folks, the opposite side, which is 4.2, over the hypotenuse, which is 6.5. Angle D equals the sine inverse, because you're finding the angle, of 4.2 divided by 6.5. Okay. Plug that in your calculator, and you should get 40 degrees. Okay. All right. So now we're going to take a look at one word problem, and this is what we're going to continue on with the next day. So hopefully this is the new piece of the puzzle. This is the new information right here. I'm sure you can handle it though. All right, number 3, word problem. A ladder is leaning against a tree. Okay, so here's my tree. Do you like my tree? Awesome. Okay, and we'll just pretend there's no branches. Okay, and a ladder's leaning against it. Okay, and it says that it forms an 80-degree triangle, an 80-degree angle from the ground. Okay, the ladder just reaches a lost cat. Okay, so we can pretend my little cat's here, like my little diagram of my kitty cat, whiskers, cute little tail. Okay, and it says that the cat is 5.3 meters in the tree, so that's the height. Okay, so 5.3 meters. Question is, how long is the ladder? So we're going to let that be x for the ladder, and we'll say let x represent ladder length. All right. So taking a look, folks, the 80 degrees becomes our angle of reference. What two sides do we have? We have the opposite and the hypotenuse. So according to SOHCAHTOA, that's your sine ratio. So sine of 80 degrees equals the opposite side, which is 5.3, divided by your hypotenuse, which is x. X is on the bottom, so we're going to do the switch. So it's going to be x equals 5.3 divided by sine of 80 degrees. So x equals 5.4 meters after you plug in your calculator. Don't forget, because it's a word problem, you need a proper therefore statement. So therefore, the ladder is 5.4 meters long. Great. All right, ladies and gentlemen, here's your homework. Page 419, number 3A, 4B, 5C, 6, 8, and 9. And again, quick reminder, make sure your calculator is in degree mode. Have a great day, guys.